So, I'm Klaas van Schelven, hello. And I'm here to talk about a project called Expressions of Change. Of course, I'm at the Clojure Meetup, but I'll ask you guys to wait with kind of clamoring, like, where's the link to Clojure for a little bit, and then I'll show you some link halfway during the talk. So what is this talk going to be? So first I'm going to talk about project motivation. I actually have like things I can click for this. And then I'll dive into some more specifics. So this is probably the part you're all most interested in, being engineers slash computer scientists slash whatever you want to call yourself. Nerds, you probably want to see, like, give us the details. And then I'll show you the demo, and it will be super awesome. So if you have any questions, be sure to ask them. And if it gets annoying, I'll let you know, and then, well, hopefully after that there will be less questions. And especially if there's something you don't understand, make sure to ask. And also kind of pause at the end of each of the chapters to see, or if I remember at least, to see if there's any questions. So what is this motivation for this project called Expressions of Change? Well, first, software evolves. So this is kind of like this number that always gets thrown around, 40 to 80%, which is kind of a wide gap, but anyway, 40 to 80% of software cost is in software maintenance, or there's these kind of like slogans, like software is either dead or changing, and any successful software will be changed. Well, I'm not sure about the 40 to 80%, but I'm sure there is plenty of projects that spend like most of their time in maintenance. So there is a big thing with software maintenance. And yet, text is static. So here's a text file depicted for you. Well, of course, we've kind of moved away from this punch card at least a little bit, but I'd argue we haven't moved away very far. So the past in our conversation with the compiler or interpreter, the past doesn't really play a role. And you can ask yourself, like, is there really a conversation with the compiler or interpreter or other tools going on at all? Or are you just kind of presenting like a single set of facts, and then the compiler talks back to you, and then you show another set of facts, but the compiler doesn't have any memory of what happened earlier. So, of course, you all are screaming now, what about Git? What about version control? We've solved this problem. We've seen that it is a problem, and then we solved it, so now we have version control, no more problem. So I'd argue this is Git, this fire escape. Why? Well, this is a typical example of something that happens when your requirements show up halfway in the project, right? So first you build your building, and then someone goes, okay, it's unsafe, and tells the whole country all the buildings need to be safe in case of emergency. And then you go like, oh, now we have a problem. Well, no worries. We'll just put it on the outside, and people can still escape. But modern buildings don't have these kind of fire escapes. If you have a modern building, you just integrate the solution straight away. And I'd argue modern programming languages shouldn't have, or rather, modern programming languages should have integrated support for modification. So, what are we going to do about it? So, kind of my solution to this problem is to take change as a primitive, or to reify program modification. So we say, okay, rather than have text files be the main building blocks in program construction, we're going to take modifications to programs and have those be the main building blocks in program construction. And like all throughout the programming toolchain, we're going to use this interface rather than just text as the interface with which these tools communicate with each other. And the idea is basically, if modification to programs is such a large part of your problem scope, maybe we should integrate it into the solution side as well. So to do that, I've kind of just said, like, we're going to reify program modification, but then you have to kind of figure out, what does it even mean? Like, what is a good vocabulary to talk about the changes to programs. What is a good vocabulary that these tools in your toolchain can use to talk with each other about the changes in programs? And that, in fact, is kind of the subject, like the main subject of this talk, is kind of talking about what could be a good vocabulary. And once we've answered that question, then we're just going to record everything, and then we'll just automatically reap the benefits, right? So this is this borrowed approach from the gnomes of South Park. So of course it's kind of a lame joke there, but so why is the slide up there anyway? Well, it's kind of the admitting that I think the goal is in that general direction. I'm kind of sure about the idea that program modification is important and we should make it part of the solution as well. But what the exact benefits will be is less sure, but it doesn't mean that I don't have any idea about what the benefits to this approach could be. So, so before kind of diving into this, the meat of the talk thing, which is this vocabulary of change, let's talk a little bit about what the profit could be. And there's two things here, two levels at which we could search for profit. So the first is to look at the level of the tooling and to make all the tooling change aware. So we have all these tools, and now they're mostly not aware of how the program changes, and we can make them aware, and then we can reap benefits. So one example would be static analysis. So static analysis being any kind of analysis that you can do of your program without actually running it. So an example could be identifying which variables are undefined, or rather, or the inverse. So you can identify which variables have been defined but are never used, or any kind of type checking. Yeah, so that's all. I mean, that's all quite useful in general. It's not even like we can do that without thinking about program modification. But if we think about, like, if we have these primitives of program modification, if we have structured information about the changes to programs available everywhere, then we can also do this along this historic dimension. So the idea is that static analysis will tell you where a problem is in your program, but if you have these modifications available to you, then you can also then you can ask your toolchain, when did my program break, or when did this kind of state that I am interested in occur? And by when, I mean at which particular modification did this happen? And of course, I think at least that both where and when are useful questions to ask, and both of them you probably ask in determining some kind of a why question, right? You're actually trying to solve something, you're trying to understand something, and then if you see when it broke, there's another hint to why it broke and how you might solve it. Okay. So the second approach is a little bit more further down the line. So metaprogramming. So again, we can talk about metaprogramming outside the scope of program modification, and then or metaprogramming reflexivity. So this is when programs can reason about themselves, and there are general usages for that. Again, also we can think about that when we're thinking about program modification, and the goal there is, well, the basic case is if you have a program, you probably have some data that this program is in control of, or somehow managing or interpreting, and if you're changing your program, then your data is kind of out of sync, or your program and your data together, they're no longer in sync. So, well, the kind of presumed benefit, the goal on the horizon here is that it will be much easier to have data migrations that will, or any other solutions that will bring this stuff back in sync again if you have this structured information available to you about program modification. But this is like the previous idea. So this one, here I actually have some implementations, and here there's not much at all, just drawings in my booklets. Yes.
I'm a little bit confused about the level of abstractions. Are we currently on, like, to which point we're returning to reinvent everything down the line? Like, are we talking about are we fixating some language and or platform, or are we going further and like I can imagine this being integrated into like even hardware somehow, operation systems, and then we have this like text barrier, and then we go to platforms, and then it becomes like language / platform specific.
Okay.
It's primitives, right?
Yeah. So my answer to that would be actually it's kind of a nice segue into this slide. My answer to that would be pick a design space. So we take a particular structure, so a programming language, a particular one. So the structure for Java is not the same, like the semantics and syntax definition is not the same as for Clojure, is not the same as for Haskell or whatever language. So we pick a particular structure that we're interested in and give very briefly a reason why we do that. And then we can think about the ways we can construct such programs.
Yeah.
So, well, that's basically a great kind of segue there. Yes.
How does this relate or compare to extensible records in languages like Elm or Haskell?
I'm not sure it does at all, but maybe I'm not familiar enough with the concept of extensible records. But my kind of, the idea is basically pick a language and then say, put the kind of like the changes to the programs in that particular language, put them in some kind of structured version control, which is then the vantage point for the rest of your tool chain.
So yeah, so in that world,
yes,
there's like this idea, papers on like extensible records, but it's just for the data types,
yes,
not specifically
that's what I thought,
for the whole language, where you see the evolution of data types as proofs of how records change through time.
So that's probably kind of on this here, the meta programming.
Maybe
part of that problem is attempted to be solved there, I think. But I'm basically putting the program source into the kind of like the thing we're examining. Yes. Yeah. So we pick a design space. Then I'd like to talk a little bit about kind of, so if you have a particular structure under consideration, then you can come up with a whole bunch of ways you can formalize the ways you can modify that structure. And I'd argue not all of those ways of formalizing that, or vocabularies of change, not all of them are equally useful. So we need to talk a little bit about, in at least some not very formal way, but get a sense of what would be useful vocabulary. And then I'll show like a particular design for such a vocabulary. And well, that's kind of tentative, but it works reasonably well, not surprisingly, given the goals that I just announced, and then we'll go from there. So this is the closest we'll get to Clojure. So the structure under consideration is as expressions. So I'm just going to say we're all Lispers here, and I won't spend too much time kind of defining it, but even if we weren't, I wouldn't need too much time defining it, because an as expression is either an atom, so that's basically a piece of text, or actually I have a slide for that, or it's a list of as expressions. And well, that is what it is. It is a list of as expressions, and if we print it, then we show the list between parentheses, and we separate the S expressions that are the elements of the list by some white space. So here's an example. Here's an S expression, and it consists of further S expressions. So it consists of this atom plus, and of this further list expression, and this atom 12. So why pick those? Well, basically, S expressions can be defined very briefly, as we just saw, and that's useful for a number of reasons. So one of the reasons that's useful is that we don't have to spend so much time talking about the program structure, and we can move on to the interesting bits as quickly as possible. But it's also useful because the more kind of complicated your program structure definition is, the more edge cases there are in your program structure definition, the harder it is, or the more kind of edge cases you will need to describe how such programs can then be modified. Or at least I think there is a very clear link there, at least if you want to kind of do it in a structured way. So there's a good reason to pick S expressions, sorry, S expressions. And another good reason is the explicit structure of S expressions when they are presented to the user, to the programmer. So as expressions, you can just see an open parents, and you know, oh, there's a beginning of a list expression, and close it, etc. So you kind of just look at the AST. And if you're modifying the AST in a structured way, that's a very useful property. And of course, finally, there's a whole family of languages that are written in S expressions. So, well, it's kind of, don't have to also think of what is the program language going to be like. Let's just focus on this idea of expressions of change first and vocabularies of change, and not also have to think too much about the programming language. So let's develop some intuitions. So first, so we're going to move to a little bit, and it's not going to be super mathematical and formal, but it's going to be a little bit more formal later. But before we do that, let's talk about some intuitions first, and because that's how people think. So what does kind of a typical story of construction in our world of S expressions look like, or modification? So this could be a story about how to modify an S expression. So you could say, oh, this is a story in English, of course, which is not very formal, but it's a story about modification. So we start with this S expression, then we remove the atom plus, and then we get this one, and then we insert the atom hello, and we get this one, we remove 6, and we get that one. So, well, it's kind of an intuition of adding stuff, removing stuff, and that combination leads to changing stuff. So what does a typical vocabulary look like? Well, now we can use our previous intuition. So we can see that there's different kinds of operations. So we can add stuff, we can remove stuff, perhaps we can move stuff, perhaps we can update stuff. And then we have different attributes or different properties for each of these kinds. So if you delete something, then the kind of stuff that you need to further specify is not going to be the same as if you add something, because if you delete something, you just have to point somewhere. And if you add something, then you need to tell what's going to be added. And there's also a certain relationship with the structure. So for an atom, there's not going to be any elements, so you can't talk about modifying the elements of the atom. In fact, you could argue like an atom is undivisible by definition, so there's really not much you can say about changing a particular piece of it. But of course, for a list, there are elements, so there should probably be modifications available that are also dealing with those elements. And then the typical design decisions, they just kind of plug into that straight away. So if you have multiple kinds, then you have to, if you're designing a vocabulary for change, you have to pick some. And if you have multiple properties, if you have multiple ways to express where to delete, well, you have to pick one as well. So now finally some terminology. That's what everyone's always waiting for. So the idea is when we're talking about formalizations of program structure, then we have words. So we know what grammars are, what parsers are, and syntax is. But when we're talking about how to modify programs, we don't have words because nobody does this in a structured way. So there's no words. So anyway, the metaphor I've picked is kind of musical notation. It's a nice metaphor when you're thinking about kind of words for constructing something over time. And I'm not going to tell you what all these symbols mean in actual musical notation. I'm just going to say, I'm not going to say vocabulary of program modification anymore. I'm just going to say clef, which is the vocabulary of program modification. And then notes are the things that are inside the clef. So I talked about different kinds of operation. Well, I can say, okay, each different kind of operation is a different note. So we have like kind of an idea of a class and an instance. So there's like adding, which would be a note with a capital N, and then an instance of that would be that particular way of adding a particular thing. And a score is just a bunch of notes that are in sequential order. Okay, and then we can use this notation. Luckily we can re-abuse S expressions to express these kind of ideas of nodes as well. So here is a node, and well, it shows like the first part of it tells you which node it is with the capital N, and then the rest of the attributes or the rest of the elements of the list can use the latter parts of the list. And if you put a bunch of these together in a list expression, you can say, okay, that's a score. Okay, so now some ideas. Is it clear so far? Yeah. Good. So some ideas about what would be useful in such a vocabulary. So first, I think it should be complete. It should be possible to get from any S expression to any other S expression, because you don't want to kind of have the idea of being stuck in not being able to reach a certain program given your set of words to modify it. Should make that a little bit less strict. I think it should be possible to at least get from any list expression to any other list expression. I'm not sure if there's any meaning to go from a list to an atom. I don't think there is, but we'll see. And then it's useful if the clef is, so here it says brevity twice. So first of all, it's useful if the definition is reasonably short. The longer the definition is, the longer the mental burden on the programmers that need to understand this definition, the longer or the bigger the implementation cost is in trying to understand, given the fact that we're kind of putting this all over your toolchain, well, then you have to implement all these different specific ways of doing it. And the second thing that is nice if it's short is if you can express, if you have a certain typical ways of modifying your program, then it's better if you can do that succinctly than if you need to kind of jump through all kinds of hoops to achieve that. Of course, that does depend on what your idea of typical program modification is. And finally, composition. So here's Hal Abelson, so we can't argue with him. When you think about the language, you think about it in terms of what are the primitives, what are the means of combination. Well, even if someone else said it, you shouldn't argue with it. This is really good advice. But what does it mean for us if we're talking about program construction as well as program structure? Well, made it more complicated than necessary, perhaps. Anyway, the basic idea is we can think about the way the program construction composition and the program's structures composition possibly interact. So, well, first, actually, there's an empty box. So if we both ignore the program structure, the way the program structure is composed, and the way we construct programs, well, then we're not doing any composition, so we don't need a word for it. And we can also ignore the way the programs are composed, but just look at the program composition. So we can say, okay, well, we can compose nodes out of other nodes, but we don't actually look at the program structure. Well, that's a way of thinking about this kind of composition. And then you can say, okay, we're going to ignore this idea of composing programs, or sorry, of composing the program construction. We're just going to look at the program structure. So program typically has some structure. That's how we understand it, and that's the whole idea of programming. Some people would argue is to kind of decompose it into parts and then bring those parts together. So to make that a little bit more concrete, you might have some modules, or first you have a program and then it has some modules and has some classes, and the classes have methods and those have statements, etc., depending on your language of choice. So one way of looking at it, if we just completely ignore the ways the program's construction might be composed, we just look at this program structure composition and can say, okay, I at least want to have history available at every level. So I want to be able to look at the history of the program, I want to be able to look at the history of a module, I want to look at the history of a class, and I want to be able to look at a single statement and see how that statement has, what kind of history that statement has. And of course, finally, you can just have the super combination of these two things. So there is, in this final way of looking at composition, there is a meaningful interaction between the way the program is composed and the way its histories are composed. Okay, so much for this kind of abstract, lofty goals. I'll just now finally present the clef that I came up with. And I'll kind of rush through it because then I can show the example, which makes it much more kind of touchable. So become atom, which is out of nothing, become this atom that you provided. Set atom, which is given an atom, and then you have this particular node, then there's now this new atom. Become list, which is out of nothing, there becomes an empty list. Insert, so given a list, insert at a particular position the S expression that you can come up with if you play that whole score that is being provided. Delete, given an index, and of course this also applies only on lists. So given an index, delete the element at that particular index. Extend, similar to insert, but rather than playing this score from nothing, play it from whatever was already there. Encode takes a score and then does also, it's basically just a composition over nodes. Now you had a bunch of nodes and then now they are composed into one. Yes.
What are those indices? Are those textual or?
Yeah, so they are numerical and they are following the holy Dijkstra, which says that like if it's 0, then you should remove the first element of the list. And
those ones.
Yes.
Okay.
So well, here is so this is actually a score. So here's two parents missing to cause maximum confusion, of course, or rather to save some space on the slide. So here's a bunch of nodes, and they are where we are to interpret them as play all these nodes one by one. And that's what we're going to do. We're going to click through it, and we're going to see something happen. So I'm going to do that slowly now. And we're going to see it happen here. Thank you. Of course. So we're going to see it happen here. We're going to construct something. So here is a score, and here is a structure, construction structure. So, well, become list. We've already seen the empty list appear. So insert 0. So we're going to take some scratch pad or piece on the stack or whatever you want to call it. And because we now have to first play that score before we can insert it. So that structure starts with nothing. And then again, we have become list. So there we have another empty list. And then we insert at position 0, become atom star. So actually, we should have another scratch pad and push that back in. But I'm leaving out some details because I'm assuming that you can do that in your mind. So okay, we do the same for become atom 6. And then we actually insert that thing back at position 0. And we insert something else at position 0. So everything shifts right, and the something else is just to become atom plus. And then at position 2, we insert 12. Now we extend, so that's the final thing that's a little bit more complicated. So in this case, the scratch pad starts with something that was already there, and we insert at position 2 this atom 9, and we'll put it back.
Is it clear? Good. Okay. Yes. Is that a yes or no? Or
how does do you know the zipper data type?
No.
Yeah. So how is it? So how is it different from that? But yeah.
Okay. We'll talk about perhaps it is just that.
What if you insert the wrong index? Like if you're out of boundary?
Well, then an error occurs, right? So that depends. It's, in some sense, it's an implementation. What happens if you have garbled program text? one answer could be at least that, right, there's a certain mapping suggested here with like who's going to create this thing, right? So an answer could be that you're editing this thing, and in the and that is actually like a large part of the answer. And by editing this thing, you're also creating, or you're actually creating rather, this score which has all the modifications. So in that scenario, as long as your editor isn't broken, then you will not create kind of errors in your score. But of course, kind of the next step could be that you say, okay, now I'm going to take this thing and it's just an S expression, I'm going to edit it. And then the question of errors pops up again.
So basically it should fail. I think that's the short answer. It should fail, there's no...
Well, and then it should fail, and then it offers some path to recovery and understanding, right?
What if someone copy-pastes something? Will you create an artificial piece of history for that?
Yeah, so that is one option, yes. So copy-pasting is actually, yeah, so it's interesting, 'cause that's one question. And then another question is, what does it mean if you're trying to stay inside this idea of modification, right? So you're, if you're copy-pasting from your own editor, is it even, do you want to preserve the history? Maybe, maybe not, might depend.
Yeah, I was just trying to see like how this relates to, because if your assumption is you start with more typical text editing way of writing and modifying your code, not everything you can do with the text will map to this.
Yes.
And even valid things that can map to this may not be very intuitive way of mapping that.
Yeah, so that's on my challenges slide. So can I come up with an edit? And this is a general problem of structure editors, right? So the editor that makes this stuff is a structure editor, kind of by necessity, because you're assuming structure on the ways you can modify it. So then you also have to assume structure on the actual thing under consideration. And then there's this question like, can you come up with a structure editor that's not horrible?
Yeah.
Were the people completely ignorant to this? What were the people at Lighttable trying to do originally?
Who? Or
Lighttable, the Clojure editor, IDE thing.
Yes, so...
just ignorant, I don't know.
You're asking me what they were trying to do. Similar things, but I'm not sure they were so much on the kind of like the tracking modification.
Yeah, they were like trying to split up all the functions and put them on the table, and like you browse that like cloud of functions, and while executing you see the results like under them or something.
Yeah, so there are links, but I think they're kind of their objective was like, or their kind of vantage point in their whole exercise
was not changing through time.
Was dealing like dynamicism in your IDE. So you have to kind of get immediate
like
responsive, like a REPL on steroids or something like that.
Yeah.
Like a supercharged REPL, and you just have to see documentation whenever you click something and see the thing executed on various values, etc. But it's similar in the sense that it is out there, like abandoning a lot of things in an attempt to see where it gets you.
Cool. So, sorry, I'm confusing myself because now this is again design goals, but now this is kind of the question: did we achieve them? So this I'll leave as an exercise to the reader, but by kind of adding, deleting stuff, and having the necessary ways to create the primitives or the initial atoms, yes, it's complete. So brevity, well, it's a matter of taste. So far it's the only clef, so it's hard to compare it. I think 7 notes is reasonably short definition. It's almost kind of the shortest thing you can come up with. Of course, you can always say, oh, there's just going to be one node which is replace the current S expression with this other S expression. It's kind of this trivial answer, or non-answer rather, to the question, but it's still, I mean, it's something that's that does the completeness thing. Yes.
The F algebras, you just said F algebras.
Okay.
Sorry.
And the other question is, like, can you express with reasonable brevity typical changes? I think you can get quite far. Like at least creation, updating, and deleting are have direct counterparts here. The open question there, I think, is moving, and should you not allow for that explicitly as well. And then in terms of composition, so first we'll look at the intraclef. Okay, so well, that I've just added it by default, so to say. So there's this chord. You can compose nodes out of nodes. So here's a score. Again, to confuse you, I've left out the outer parens. And of course, now you look at these first two things and you say, oh, these things are related. I want to group them. Well, that's okay. You just put them in a chord. And then we'll skip the second thing because it's directly implied by the third thing. So, is there a meaningful relationship between the clef and the program structure? And well, indeed there is. So first we have to figure out what is the structure of S expressions. Well, I already told you it's the main way to compose S expressions out of other S expressions is the list expression. So here we have a list expression, and it consists of these three parts. And what is the means of composition, or what is a means of composition on the side of construction? Well, we had scores. So again, this time I did draw the outer parens to confuse you even more. So scores consist of nodes. And now there's this question. Here's the full S expression, and well, that's the full score. And those two things have, like, this is the score that if you play it, you end up with that S expression. And if you were to ask this S expression if it has a memory other than the thing you just see, and you asked it, which is kind of implied, right? This is the goal. We are trying to understand things in terms of what their actual history is. So if you ask here, what is the history, you get this answer back. So now the question is, what's the history of this thing? And it's kind of trivial. It's only been created once. It's never been modified. And the same is for this 12. And this is the less trivial one. So this thing has been first kind of like has these 3 steps in its history, and then later we revisit it, and there's another step.
Kata and ana.
Sorry?
Catamorphism, anamorphism.
That's
what you just did.
I'm not sure that's all I just did, but
4 S expressions. But yeah.
Okay.
In your algebra. Sorry.
Okay. You'd have to explain that to me later. Well, okay, so let's do it then.
Okay. So, of course, to confuse you slightly more, this is a slightly different version of the, or I should say outdated version, or not up to date with the notation that I showed you earlier. But, well, I'll show you what I have in kind of a radical honesty. I think I could. The contrast I cannot. Let's see. Is it enough increased? Okay. Okay, there we go. So, well, I think a main thing here is that I'm maximally confusing you here by using a different set of symbols on the left. But I'll explain a few of them. So if you look at this, if you see a T, that's kind of like the creation of an atom. And so here we have a star, and here we have a 6. So those are atoms that have actually been created. And N is for creation of lists. So well, I haven't actually shown you any editing. I can do that in a sec. But one of the kind of the main payoffs is this idea that you get this history at any level if you have construction or if you can construct histories out of histories. So here we have this this particular kind of sub-expression, and on the right I clicked, and now we see on the left the history of that particular sub-expression in terms of first it came into being, and then we added the star, and then we added the 6, and then we added the 9. And now if we look at the whole thing, we can still see that, but it's not actually like it hasn't actually happened in directly consecutive order. In the meantime, so first I actually added this plus. I didn't actually do that. First I created the sub-expression, and then I should show it here. First I created sub-expression, then I added the star, then I added the 6, then I went and did some other things. So I created the plus and 12, and then I went back and created the 9. So it was a very quick demo. And to avoid further...
you did have editing for the 9, right? You went back into the record select, I guess is what RS means. RS? I don't know. But the times 6 was already there, and you inserted it in space 2. Trying to interpret.
Yeah, so the magical symbols, the R actually means extend, so it's replace rather than extend, and the S means that this index is expressed in terms of its spatial position in that particular list. So the reason is you can think of you can look at this expression and say, okay, I'm pointing there and I want to see something there, but there's also some that also creates some kind of obfuscation, because when we first added this sub-expression, it was in position 0 because there wasn't something before that. And then when we come back to extend it later, we're extending at a different position in space, but it's still the same thing. So if you switch to kind of this view of things in their time index in time, so to say, then you can see that it's actually the same thing. So now it's 0 in time, and the extension is also in 0. Of course, that's like a super ugly way to do it, right? So that's up for the future.
So white space is not part of the equation. Indentation, white space, these sort of things.
You mean kind of the layout of?
It's not part of the history. That's what I mean.
No, that's another open question.
Setting in your editor, just like I want this indentation ruling. This is my expression. Formatted for me.
Yeah. So there is some like I have some thoughts on that, but not ready for presentation. Like I can change the layout, but you're right. This is just kind of like outside of history, right? It's gone when you close it and reopen it also. But there is some opportunity to do this, like because you have the historic information. So you know, you can also kind of annotate your history with another thing that's just going to say, okay, this thing happened, and then we change the layout in a certain way. Okay, I'll show this back at the end.
So, well, the future, some upcoming plans. So make the editor somewhat more useful. First of all, bring it in line with the actual presentation, but also make it a little bit more friendly to people other than me, and actually usable to like do a minimal subset of scheme and write some programs in that. Another part of the thing that I really want to get up and running is these visualizations. So now we have this super cryptic stuff, but it's kind of a waste because there's super awesome granular information about program modification available. So and not just at small granularity, but also at arbitrary granularity. So if you group stuff into these chords and then group those chords into other chords, then you can have meaningful pieces of history and then drill down into that and just visualize it in all kinds of ways, like even three-dimensionally, because, well, time is another dimension. So lots of plans. Hope to bring that up in the coming months. And then finally, collaborative editing. So there's another kind of, if you have super granular information about and structured information about program modification available, then this 60-year-old dream may finally be like a little bit more achievable. And there is a hint, like collaborative editing, it never really works, right? If you have all these solutions that almost work and then they work poorly enough for you to not actually want to use them. So the thing that we actually did manage to work out as software developers is collaboration at the kind of commit, Git commit level or version control system commit level. So I think there's a hint that if you have good information about modification available, then you might crack this problem. Of course, the granularity in this is much smaller than this Git commit. Yes, questions?
Thinking about that, isn't one of the reasons that Git works pretty well for collaborative editing is because you're sort of independent branches. You're working in your own space. You're not immediately
sure. So I'm not
bothered by what.
I'm not implying that there should only be one mode which is kind of plugged into the big machine at all times, right? Yes, that's part, like the ability to unswitch and switch back into the main collaboration somewhat arbitrarily. But it should be a programmer choice, right? It shouldn't be, oh, I can't collaborate on keystroke by keystroke level because Git does. I mean, Git could allow it. You have to, I don't know, commit and auto merge things, and then also have your editor auto edit, and then it's gonna break precisely when you would need it, right? So anyway.
Sorry, I missed I would like to, probably you covered this in the beginning, but it's the idea that instead of when I save the thing from this editor, instead of saving my source code, I would save this left.
Yeah, so you or store, so you would the thing the main building block is no longer the thing on the right, but the thing on the left. So the history that underlies your program construction is kind of the primary source, and the fact that you can automatically collapse that into a particular structure is secondary.
I can see how it would tap into the anxiety of a lot of developers.
Sure.
Every stupid thing I did, even before I saved it, is already visible.
This is I have a slide for that. So that's one of the questions, right? So the normal approach is kind of forget everything and be super specific when you want to remember something, which has the drawback that there's some things that you might would have liked to remember, but are gone.
Like
but of course, if you turn it around, you have like save everything. Then you also have this big mess, and part of editing perhaps is kind of exploring and not going in a straight line to where you want to be. But then if you collected everything, that would be annoying. But I also have some answers on kind of like, there's some things that if you go somewhere and go back, that you can auto collapse, right? Or can at least offer your programmer to say, do you wish to show this path that went nowhere? And then there's this idea where you take the whole screen and kind of put it to the right and edit your, which is the thing we talked about earlier, when you edit the history, and you can track the editing of the history as well.
Yeah, maybe that's a good example, like when you undo, like I sometimes do it, I undo, then I change something, and then my redo history is gone.
Yes.
And sometimes I miss it, because maybe there was something actually good there, but once I had one keystroke after the series of undo, I can no longer go to...
Yes.
Yeah.
This is...
So you would save me from that.
You
would save me from that.
This particular idea of shifting, like if you edit history, you shouldn't be kind of unhooked from the wall, and like there's a similar problem in Git, right? We want to rewrite history in Git because of very similar reasons. Like there's different values at play. One of the values is tracking history as it actually happened, and another value is showing this perfect history, which because we use the history to communicate about what happened, and that there's intent and meaning there as well, and that's why we rewrite history. But now in Git, the only way to kind of rewrite history is to kind of like take away all the safety that Git gave you, and then like, oops, I did this -f, and now the company's gone or whatever. Of course, that shouldn't happen, but still, you get what I mean. Like there's no, you can't apply Git on Git. Yes.
I watched a little bit of your lightning talk before, and I thought one thing that I thought was really interesting, like making the history available to the program itself to kind of like, you know, take that into consideration. I don't know, like to maybe change itself, or like, you know, I don't know, like you were talking about like data migrations, right? Like knowing like, oh, maybe you have a snapshot of point in time, so I know what transformations I was applying at that time, so to make, you know, just to kind of like, as you said, like, you know, take that change into consideration. So I thought it was really interesting.
Yeah, so that is in kind of like in the furthest future, so to say, like we currently, like, there's lots of solutions, and maybe you mentioned one, and then, for example, in the Django world, you have like this data migration, and it just looks at your Django specification of your data model, and then looks at some other thing that is specifically created, and compares those, and then guesses what happened, and then migrates your database accordingly. But you have to manually check all those things for good reason, because the guessing is it's based on heuristics. But it's kind of so sad, because you change those things so that you know why you did that, and then there's no way that the information is stored, and then you have another layer of stuff that is also disconnected from your version control system that attempts to kind of salvage your data along with your program. So there's kind of the sadness there.
Maybe it's an opportunity.
Yeah, sure.
But that would mean you have to like also put in your data that you're not talking just about the code and the structure of the code, but you're also talking about anything that you basically store and process in your program while it's running.
Yes. Yeah. So
would have to be part of that. So you would have this very dynamic system.
Well, at least the kind of the type information, like the data would need to know which version of the data it is. So there needs to be kind of some information about what data it is, and how that compares to the running program. And so it's by no means solved. Otherwise, I would have shown more on the slide. Yeah.
In your Django example, you mentioned that you also you want to know why you made a change. And if you track changes in this granularity, with Git you can make a commit message, and with some changes you can put a message as to why, or what you're trying to do. But if you track everything all the time, where would you put this?
Yeah, so that's also kind of not depicted, and only kind of like I'm kind of suggesting that it would happen, right? So the vantage point in this editor is to just record everything and then have that. But the next step is to say, okay, we record everything, and now we can offer these mechanisms for structuring. So you select a bunch of things and say, okay, this is a chord, and this chord represents your commit. Or you have like there's another thing that also saddens me. It's like in Git you have commits, but there's like just one thing you can do. You can commit, but often when you commit, you have a refactoring that has different parts. But there's no way to structurally express basically that it's like a 5-commit commit, which is something that I at least often kind of just write it down in your commit message, but that's not structured.
I don't know whether it's a question or just a rant. I'm thinking about workflow and the semantics of this chords, like how do we divide things into chords, how does it relate to what we're doing. So for example, I have this block, and during my work I create 2 more blocks. Up there I change a bunch of things here, then here, then here, then return here, then return here, and it generates a lot of class. But if we think about, and like I want to present the end result as a chord, as like my what would be my commit, and I've been thinking like if the implementation treats these modifications as kind of algebra, it can like optimize this thing to minimize the changes so it will say like add this whole block.
Yes, yeah, sure. So there is already this idea of locality, right? That's kind of this talk about how the structure here relates to this stuff, and you can see that this, like in your algebra, you can see that this and this pertains to the same thing. But here it's hard to see because here we use these spatial indices, so you have 0 and 1. But again, in my list of dreams, there is this thing where you just say, okay, I have this 50 things that I did. Now I don't care the particular order that I did them in my editor. I want them grouped by structural locality.
So you propose to save all of this. I was just thinking if it's useful.
Oh well, and then if you do that first, then you can kind of see more things also about that paths, and maybe you have another idea.
Yeah, but maybe I want to do that because if you do that, then if you start to implement something like auto merging, that would be like more straightforward to do like automatic / manual merge. If there is another chord that you're merging into your chord is all over the place, it will be hard to merge blocks, and the resulting structure will be awkward. So maybe this is a feature, like to say to this editor or implementation, please collapse everything that I just did. This should be like in Git commits, you don't see like I deleted this.
And then sure. So that's definitely an idea to offer automated solutions that say, okay, I want no dead branches in my dead things that I reverted myself. Are we still on the same?
Yeah. And
sure.
that I think will bring more meaning.
Yeah, sure. So
chords. Like how do we divide things?
Sorry, would that end up in the history or not?
Yeah. So I'm kind of throwing that question back to the programmer, saying to a degree, right? So I'm saying, okay, let's start by recording everything, offer tools to clean up to a large degree automated or make choices that have the most of the work done in an automated fashion, and then kind of for the programmer to wrap that up nicely. At least when I commit in Git, well, in Git it's not commit in air quotes, right? It's an actual commit. So when I commit in Git, then that's an opportunity to look at, to consider my sins and find things that shouldn't go in the commit, etc. So I think that process of like, oh, this is something I want to share and clean up for sharing, that's just a real thing. So, but that's not, you can do that here as well, just in slightly different ways. And then the throwing back to the programmer part is where, I mean, if you don't want to do that, or if you can still say, okay, I want to show some dead path that I did for some good reason. Maybe not a dead path, or I want to, like if you have this locality, right? Here, this is the order of events. So there could be good reason to say, okay, just put it all together, because it's more clear. I just forgot to add that 9. It should have been there all along. This is so trivial of an example that's hard to say, but could also be that this bunch of things is part of the thing that really went first, and this thing, even though it's closely related in space, is really conceptually very different and should be different place in your story.
Have you considered adding one, let's say, one verb to express annotation? Because I think many of the use cases people present.
Yeah. So yes.
White spaces, attaching a commit, a reference.
Yeah. So yes. I just haven't done it yet because I want to do it well. But yes.
And
surely. So for courts, would like the commit message. Say, should go on a quarter. Should say. Any note we should be able to annotate, like here we call it comments, right? Mm-hmm. And this commit message is basically just the comments on time. So.
To capture the intention, it seems also that you do sometimes things like let's say renaming. Like if I do bulk search and replace,
yes.
and then it would, as I imagine, it would create a lot of clutter, like change this to this, change this, like the set atom, yeah, set atom.
Yes.
Maybe that would be a nice, one nice thing. But also, it's a whole class, I think. Like also, like lifting something,
Yeah. My current answer is to not express kind of such kinds of meaning as nodes in the clef. You could say there should be a rename node which takes an S expression, finds all the atoms that have a certain name, certain value, and replaces them with another atom. So I haven't done that. I'm not sure. I'm not sure what the best solution is. Right? You could imagine that that the editor or IDE or whatever collapses onto very relatively small clef, and I'm not sure. Like if you start adding more and more things that have meaning, will it ever end? And then there is a cost. So there's also this idea that you could have like a clef in your IDE which has all the meaningful things and just collapse. But I'm not entirely sure where that goes and if it leads anywhere. But I did think about it, but not fruitfully.
Rename kind of things like typical refactor, and if you're working with multiple people, if you have branches or separate histories and you need to merge them back together, it would be very useful for that.
Yes.
Yes,
that's true.
Meaningful.
Yeah. So to be honest, like my first next candidate would be moving, because well, it doesn't kind of. I've talked about S expression, but this looks like Lisp, and well, this would be valid Lisp, but I haven't actually committed myself in these nodes or in this clef to it being an actual Lisp. And of course, like if you're going towards renaming, you're also already assuming more semantics of what the S expression means. And for moving, that's not the case. And moving has some nice properties that you kind of have this idea of preservation of history. So you switch two things, and the things, like you assume some kind of identity that these things have. This is what moving is. Yes.
You said that this can be helpful for collaborative editing.
Yes.
But if you have very different histories, like you start from
Yeah.
the same point and you diverge a lot,
And you get to the same place.
Pick something from one place and from another place. In Git it's easy because it's just that. But for this one, how do you merge?
Yes. Well, there's a lot of work to be done, but I can say some kind of fundamentally. I think it's both easier and harder. Because I think it's easier because your information about your about the structural changes is much more precise. So, for example, if some person changes this star and another changes this 9, then you can, I think, reasonably, well, besides the semantics, of course, right? But you can see that this is not the same thing. So, okay, that's great. But the thing that makes it harder is that if someone reaches a particular state using one path and another person reaches the same state using another path, you kind of have to make a value judgment about what that is. That the same should we just merge that? There are different paths. So what does it mean? You're raising a whole question of semantics there.
Yeah, actually, if versus Git, we would just do the line. The Git would say, well, the line changed in both places, and I can't merge it safely. But with you, there would be different points in the tree.
I'm talking actually about like if two people make the exact same change. I think Git says, okay, that's fine. Then they must have meant the same thing. And you could even raise the question of semantics there, right? I mean, it's not necessarily for each piece of text the right answer, right? If your text file is kind of like payments, and two people add, or like two computers
one does
represent
the star first,
the
then
same
the 9,
payment.
the other does the 9 first, and then the star.
You're confusing. You're not listening to this particular example. So from two computers, the same payment comes in. Git would just say, okay, same information, that's just one thing. But really, there's two payments happen. So it's kind of double spend.
Yeah, and both. What should have happened?
Yeah. So, but the thing is, that depends on the semantics, and Git
That
makes
will
no
generate
statement
conflict.
about
Do
semantics.
you know whether it will generate conflict?
I think Git says it's just
It
it's
depends on your merge
okay.
strategy. You can set it to actually add, in this particular case, so for change logs and things, you can set a different merge strategy for Git because it doesn't know and it doesn't care really. It's sort of, you can plug in even different programs to say what should happen in this case. So you can make it work with add things twice if there are two changes that add the same thing. But by default, it would see that as one change, and like it would merge that in.
And the other question, like if two people reach the same state through different paths, that like if that happens inside two single commits, then Git doesn't even. That's just a problem that Git doesn't know about because Git doesn't see inside commits.
So we say there would be two separate commits.
Then I'm not sure what Git says. I think Git is pretty happy on the if the result is the same, I'm fine with it.
So basically, by doing this, you accumulate like you represent writing code, implementing the program as data. Do you think it started as a joke in my head, but more I think about it, getting more serious. Do you think it could be used for some kind of machine learning, and then to have computers learn to write meaningful code? If you get a lot of data like this.
Well,
you're a dangerous person. I'm
I don't know. But your question does trigger another question in my mind. It's like the reverse. There's people working on the reverse solution, right? So I'm saying you should just record what actually happened, and you should be very restrictive in the ways you can change your structure. But there's academics working on looking at programs and then saying these are not just text files, they are ASTs, and what is the meaningful change, what's kind of the shortest meaningful change between this AST and this other AST. And as far as I understand it, that's a very hard problem actually. Maybe insolvable.
Yeah.
Wait, so do you have two parents? So it's super trivial, huh? To become atom, you have two opening parents. Why? It's by design, or?
Oops.
Because it's a list of
operations. Sorry. So why am I? What's going on here? So
yeah.
here, right?
For example, here.
Yeah. So actually, yeah. So this is a score which contains a single note.
Okay.
Answer.
Yeah. And second, did you choose the number in random or not? Because if you put a minus, you have 42, and it's quite nice.
I'll change the slide.
Yeah, very good.
Of course, I'm not assuming any semantics here.
At least it has 69.
Okay. So, just to be complete. the future. Yeah, so this is a similar kind of concern, right? So it's are we able to do structure editing in a way that doesn't hurt? And this I've talked about its length, and this is implied, like all the stuff I said about why S expressions are a great object of study it's true, but the problem is that all the other things may not be such a great object of applying these kinds of ideas on. And you could say, well, the next language should maybe not necessarily be an S expression, but should take this into account, right? In the middle ground.
You manipulate the ASP after all.
Yeah.
Yeah. So yeah, but I mean, you can manipulate any AST in a structured way, but if it's an AST which is defined in terms of like this super big grammar, then the pain for the programmer is going to be really hard.
Feels hard-headed in JavaScript or something is really terrible.
Yeah.
Let's think of languages with optional syntax. I'm not going to mention anyone right now, but depending on things you're editing, you might actually be representing fairly different ASTs depending on one comma.
Yeah.
Yes.
So that can be challenging as well.
Okay. Well, I think we did this at length, and you can look at the website as well. Thanks.
Thank you.
One extra question. I think the software is running on Meetup.
Yes.
How is it built?
I mean, what you mean? What the actual editor? So that's kind of. I'm glad I stopped. I didn't actually stop the camera yet, but maybe it ran out of battery. So it's built in Python, which is kind of like this is the thing I'm most fluent at, and that's why I started at that. Like the project is radical enough as it is, but okay. So it's kind of. You would rather have, if you're already making something in S that manipulates S expressions, you might want to consider a language that is doing S expressions.
Sure.
We'll see what's next. And one more thing about this NixOS, so that's also kind of like, that's some point where I did bite the bullet. So I'm kind of complaining all the time about software doesn't have proper historic, doesn't deal well with the modification. So let's at least do the OS that that sees that as a problem and tries to solve it. So, thanks.
So I'm going to steal the